Welcome back, Frank and friends. I'm Greg Smith, aka Dr. Francintosh, and today I have the first entry in the Offline AF series, the Offline Puck. So here you can see the Offline Puck on the left. It's a Raspberry Pi 02W in its standard case, connected to a Bluetooth speaker. And on the right we have our first dumb terminal, which is a Raspberry Pi Pico, which is driving a two-line display and connected wirelessly to the Puck, playing music, so as an MP3 player. But it's running software called Syncthing, which synchronizes files with the brick, the offline brick, which I'll talk about later, and MPD, which is an MP3 service. So without any input or output devices, this all by itself acts as a file server and an MP3 player. Oh, by the way, as usual, please don't like this video, don't subscribe to my channel, don't click up there or over there. Your time's precious. Please don't waste that on anything I'm doing. But as always, thank you so much for spending part of your time with me. And so let's get started right after this. If you remember from last time, Offline AF is a ecosystem where our files and compute services are on one device, but all of our I/O are on other dumb terminal type devices. So before we get started, let's take a look at the requirements we have for our offline Puck. So first off, we want a self-contained unit that has Bluetooth so that we can drive speakers, headphones, and do some control. Also, we're going to want Wi-Fi, both to control the device and also to do file sync at the end of the day. And we're going to want some software to do file sync, to pull in new files upon docking, and then also to delete seldom used files or large files to make space for when we pull files from our brick or our tower unit. And finally, we want it to be MP3 capable. Now, when picking the software to use for synchronization, there were many to choose from, and I settled on three to analyze: rsync, ResilioSync, and Syncthing. rsync has its advantage of being everywhere in the Linux ecosystem, works on practically every device. It has the disadvantage of being kind of difficult to set up. And then ResilioSync has a separate problem. It's a very powerful tool. It's really good at showing you all the files that are available to you, but the way it does it is by creating sort of ghost or placeholder files. And over time, I found that Resilio's placeholder files got very confusing. Resilio got stubborn about actually replacing so-called placeholder files with actual files. And then finally, there's Syncthing, and that's the one I settled on. Syncthing has the advantage of having a sort of blacklist file, so you can list folders and actual files that you do not want to be synchronized. This could eventually be how we implement purging of large files that we want to replace with newer files. It's not a perfect solution, and I believe that down the road, we're going to have to create a database of files that are on the device versus available on the remote device, and so that when we dock and do file synchronization, we have a more intelligent system. However, for our prototype and getting started, Syncthing became the file synchronization tool of choice. Okay, so we're now going to install Syncthing on the Mac. Now, in my GitHub repo in Offline AF, you'll find scripts, and within scripts there's macOS and Raspberry Pi 02W. So we'll go into the macOS folder and open up the Syncthing install. So this is a .sh or bash shell script, but you really shouldn't run this directly because there are comments in here about the file that you need to paste into your plist, for example. So the first thing we need to do is go to our temporary folder where we're going to download the software. Now, we want to work with a specific version of Syncthing 1.19, and the reason is that over on the Raspberry Pi 02W, it's only running 1.19.2. There's a version 2.0 which has a different protocol. We don't want that one. And because Homebrew installs the 2.0 version and we can't pin the version that we want, we actually have to install from the Syncthing GitHub release folder. So we'll grab that, download it, great, and then we'll unzip it and move the Syncthing executable into user local bin. And just for good measure, we'll set it to executable just to make sure that it's an executable program that we can run. Let's verify that it works. And as you can see, Syncthing 1.19.2. Now let's run it in the background and it will generate a config file. And you can see here that it's given us an ID, and we're going to need to save that someplace safe. All right, so now that we've saved off our app key, let's log in and verify that the UI is working. All right, let's take a look at localhost 8384, and as you can see, we are now running. Now here it offers to upgrade to 2014. Do not do that. We want to make sure that we're using 1.19. All right, so now that we've verified that it's up and running, let's go ahead and get out of this. And we need to set it up as a server. So let's create a folder for our launch agents if it doesn't already exist. And then let's create and edit the com.syncthing.brick.plist. Now, this is the name I'm using, which is com.syncthing.brick, because this is my offline brick device. And we're going to put this plist file into that folder, and that is going to define how we update, and that is going to define how we run our Syncthing in the background. Okay. And of note here, you want to make sure that the key is equal to the name of the process that you've created. You want to make sure that it finds user local bin Syncthing, and we want to specify -no browser because we don't want this to run in, we want this to run in a headless mode. We also want it to start up at load time and to keep alive so that if it fails, it will come back on again. For logging, the output is going to go to syncthing.out, and for errors to /temp syncthing.error. So we've got that all set up. So let's now load it, and we are good to now set up our folder on our local machine, on our brick machine. Okay, so let's log in to Syncthing, and we'll set up our first folder. We're going to add a folder. We're going to call it Music Library. Give it a folder ID. Now I'm going to give it Media Music, and that's the folder ID that's going to be the unique ID of media music all over my network. And Plex/music, and save that. So now it's scanning, looking for the music. It's finding 13, 27, 92%, and there we go. So now it's found our entire music library of 13 gigabytes and 4,381 files. So we're done now with the brick. Now let's go install this on the Raspberry Pi. All right, so now let's log into our Raspberry Pi and let's start setting it up. Again, go back to our scripts folder, RPI02, Syncthing install. So we'll do our setup update. Great. Install Syncthing. Now we're also going to install LSOF, and now we'll run Syncthing to verify that it works. And indeed it does, version 1.19-2, and so we are up to date. Now, let's run Syncthing in the foreground, and you can see that it is also creating all of its config files. Okay, so we'll stop it. Now we need to enable Syncthing as a service, and then start Syncthing as a service. Now, one thing that we need to be able to do is run Syncthing as if it is my user ID. And so we need to enable linger for that. And we're going to create our media music folder. So we're going to store all of our media. So now let's start it again and check its status, make sure it's running. and it is running. And let's check its socket to make sure it's listening, and it is listening. Now let's go check the system config, and one thing we want to verify, the GUI is enabled, and as you can see here, it is enabled, but the address that it's using is 127.0.0.1, and we're going to change that to 0.0.0.0. This opens it up to the entire network, so we can log into the server from anywhere on the network. Great. So now let's restart Syncthing, and let's verify that we can get to it from the Mac. And we can, so there. So it's allowed access from anywhere, so you may want to change the password. I'm going to go ahead and set my password now. So now it's asking me to log in. So at this point now, our folder, our default folder, has not been set. So what we want to do here is add a folder. Meanwhile, back on the Mac, one thing we really want to do here is that we want to make sure that we have set to send only, right? So now back on the Pi, one thing I want to do here, I do want to change my settings, save the theme to black so that it's easy for me to see that I'm logged into the Pi, and over here in white is the macOS. Now, we need to pair the puck with the brick. And the easiest way to do this is with auto discovery. So if both are on the same LAN, all we need to do is go into the brick and it will pop up a new device and we can accept it. So let's go in here. Okay. You can see here that our identifier is WPPKW3. So let's go back to the Mac, add a remote device, choose WPPKW3V. Now back here, since we tried to connect it, we now need to add that device. And you can see QMJ is our brick, and it's my Mac Mini. Let's save that. And now we're connected, and you can see here we are connected. So now let's add a folder called Music Library. And the folder is going to be Media Music, and save. And of course we want to set this to receive only. And now you can see that it's starting to synchronize. It sees that there are 4,300 files to get. And down here you can see the current state is that it's got 6 files out of 560 folders, and it's slowly loading them. And we can watch this. We do an ls-la in our media music folder. And you can see that the folders are starting to get filled in. Now we can see that there's a total of 13 gigabytes to load. And currently it's got 105 gigabytes. So this is going to take a while to load up. All right, so now that we've got everything working for our synchronization, let's go install Bluetooth. So let's get started by doing a set apt update. Now while that's doing the upgrade, let's talk a little bit about the Bluetooth stack. So at the very bottom of the stack is our Bluetooth hardware. To get at that hardware, we're going to need BlueZ. And BlueZ gives us a Bluetooth protocol. And then on top of that is Pipewire, which gives us the audio graph. And then on top of that is Pipewire Pulse, which gives us the Pulse Audio API. And finally, we have our own application, which is going to be MPD, or the MP3 daemon server. So we can run our MP3 files over Bluetooth. So we've got to make sure we've got this entire stack installed. So now let's go install the Bluetooth libraries and the Bluetooth utilities. So having done that, let's go install MPD, which is the MP3 daemon. Now there's also MPC, which is the MP3 CLI, or command language interface. Now, under other circumstances, we might create some global folders for MPD, but because the Bluetooth services run under a specific user, and in my case it's user Greg, we're not going to do that. We're going to set up MPD to run under Greg, and we're also going to set up the Bluetooth to run under Greg. That way they're all running on the same user. So let's go create a folder for our playlists, enable the service for me, and once again we want to make this service linger for Greg, the user, myself, Greg. And now let's start it. And let's get the status and see how we're doing. Alrighty then. So now the music player daemon is running in the background. Now here's our mpd config file, and we're going to need to put this mpd.conf. Okay, and so you can see we've set up our media music folder. We've also set up our playlist directory, and we've defined our database and log files and also the state. So we are very much ready to start running. Now we need to connect one of our speakers to the Raspberry Pi. So we'll do a Bluetooth scan and connect the speaker, and we're good to go.
Bluetooth connected.
Okay, so now I'd like to demonstrate some of the things we can do with MPC. So the MPC is the command line version of the MP daemon, and we can control the daemon by doing things like MPC clear, which clears the playlist, and then you can see here that the volume says NA because nothing's playing. We're in repeat mode. We're also MPC random off. Good. Now let's do MPC search for an artist with the name Tonal in it. And here you can see that it's found a bunch of tracks from my favorite band from my Philadelphia days called Tonal Poems, and their album was Gordon's Cave, and they had 15 tracks. Now let's see if we can add a track, add track 3, and do an MPC playlist. And you see track 3 has been added. Now let's do an MPC add, and we'll do another MPC playlist. Cool. We have 2 tracks. Let's do an MPC play. Nice. So it looks like it's playing. Let's do an MPC status. And now we get the full status. The volume's at 100%, the repeat is off, the random is off, single is off, and consume is up. Let's do an MPC next. And now you can see it's gone on to the next track. Volume's a little loud, let's turn it down. And now it's gone down to 50%. So this is all well and good, but we don't want to control our MP3 player from our shell, right? What we really want to do is be able to control it from a remote device. But in order to do that, we need some sort of wireless interface. Let's do an MPC stop. So what we're going to do now is we're going to want to run a service that I built, which is written in Python. It's based on Fast API. It has an endpoint called MPC. It takes a command and it takes arguments. In other words, we can do everything that MPC can do, only now we can do it wirelessly through the browser, sending an URL to our Raspberry Pi puck. So let's take a look what that looks like. So let's do the first command, which is an MPC clear. And so what you can see here is we have RPI offline O2 at 8080 /MPC question command equals clear. So now we're going to send an MPC command directly to the Raspberry Pi. And as you can see in the browser, it says that it ran MPC clear, it got a return code of 0, which is a success, and here's the status. Volume NA, repeat is off, random off, single off, consume off. And nothing came out on the standard error. This is good news. Now our app is running and we're controlling it remotely. So let's do that search again. Let's do a search for tonal. And we print this, and it says right here that it did an MPC search artist tonal, and it returned Tonal Poems, Gordon's Cave, track 01, new line, Tonal Poems, track 02, etc. So now if we write, let's say, a web-based application, we can hit our MP3 server and control it using the web app. Now let's go ahead and see if we can't add a track. So we did an MPC add, it returned to 0 with no standard out or standard error. So far so good. Let's take a look at the playlist. What's in the playlist? Pretty print. And it shows us that Tonal Poems track 12 is in the playlist. Now let's go do an MPC play, and we should hear our music. Yeah. It's a little quiet, so let's turn it up 100%. So we've done it. We have a puck device, which is a file server, and it also serves up these files to a speaker, and we have a way of controlling it with our web browser. So the next step then is to build a remote controller. And you've already seen the result. There's a handheld controller. We'll do this in the next episode. But this is just the first step. There's a lot more work to be done. But now we can take our puck, we can travel with it, we can listen to our music and control it with a remote device. We have multiple devices we can use. We can use a browser, we can use a handheld device. But the big idea here is that this now is a personal file server, and we carry it with us wherever we go. We have a subset of the files that we care about, and we can do whatever we want with them. And I think you'll find as we move further along in the offline journey that there are going to be a lot of other things we can do, and we'll have a different device acting as the dumb terminal into our puck. So, as always, thanks for watching. Please don't like this video. Don't subscribe to my channel. Don't click up there or over there. Your time is precious. Don't waste it on anything I'm doing. But as always, thank you so much for spending your time with me, and I'll see you next time on Dr. Francintosh.